we are now ready to solve any non-defective constant coefficient FOLSDE. Are you ready? Here it comes. There it is. That's the solution. You take the matrix exponential and apply it to any vector, you'll get a solution to this equation. Let's verify that real quick. This vector x0 is constant, so it just comes out. And we already saw that as long as you define something using the Maclaurin series for the exponential function, we know how to differentiate that. And e to the at x0 is x. So that's it. That's the formula. That's the recipe. Let's do an example. Let's take a look at this system. And the first step is to rewrite it as a matrix equation. So what we need to do is to find out the eigenvalues and the eigenvectors of this matrix so we can compute its matrix exponential. I'll go ahead and compute the characteristic polynomial for you, which gives us the eigenvalues. Now we better find the eigenvectors. We do that by row reducing. I skipped a few steps there. We can take this row reduced form of the matrix and turn it into the equations x1 equals x2 and x2 equals x3. So the corresponding eigenvector has to have all of its components equal. We do the same thing for lambda 2 and lambda 3. That gives us 2x1 equals 2x2 minus 3x3, which means there are two free variables, which means we get two corresponding eigenvectors, which we can call 1, 1, 0 and 3, 0, minus 2. So then we use that to compute the matrix exponential and our solution, which is the matrix exponential times any old vector x0. Now I want to point something out, which is that if x0 is any old vector, a vector consisting of arbitrary constants, then the vector, which I'll call c, that I get by applying S inverse to x0, if x0 is allowed to be anything, then c can be anything. So let's call c c1, c2, and c3, and then we can go ahead and compute x using c1, c2, and c3. If you multiply s times e to the dt, since that's a diagonal matrix, you just end up scaling each column by the corresponding diagonal entry, and then we just have to take a dot product. So you see, we get our general solution with three unknowns that we have to figure out: c1, c2, and c3. Okay, that actually works in general. So now we know how to solve any first order linear system of differential equations. If the coefficients are constant and the coefficient matrix is non-defective, we just have to find the eigenvalues and the eigenvectors of A and put them together according to this recipe.